Hi everyone. In this video, we are going to start on angles and triangles. We will be looking at some basic terms and notations that you must be familiar with, the types of angles, and simple angle properties that you must know. So you may refer to page 40 of your notes and take down the necessary notes as we go through these basic terms and notations. Now, the first thing we are going to look at is the definition of a plane. Now, a plane is a flat two-dimensional surface. So, for example, the floor of your house, the flat floor of your house can be considered a horizontal plane. The surface of the wall on your house is also considered a plane. So, the wall would be considered a vertical plane. So, a plane is a flat two-dimensional surface. What you see on the screen right now, this gray rectangle is actually a horizontal plane. Next, let us look at what is a point. Now I'm going to place a point on this plane. So a point is basically a particular position on a plane. So it has no size. So the point A in this screen refers to that particular position. Next, let us look at what is a line. Now, what you see here is a line passing through the points A and B. Now, a line is basically made up of infinite points. So this line, you can see that it goes on infinitely in both directions. So it has no endpoints. Okay, in contrast, a line segment, for example, this line segment AB has a starting point and an ending point. So this is considered a line segment. A line segment, you can find the length of this line because it has a starting point and an ending point. Now again, in contrast, a ray has a starting point, but it continues on infinitely in one particular direction. So this is a ray that you see that passes through the points A and B and continues on forever in this particular direction. So this is called a ray. Next, we are going to look at what is a vertex. So what I have drawn here is a triangle ABC. The points A, B, and C are called the vertices of this triangle. So a vertex is basically a point where two lines meet. Vertex is the singular of vertices. Okay, so you may want to capture all this on page 40 of your notes. You may want to pause the video here and take down the definition as well as to draw the examples to demonstrate what each of these means. Next, let us look at the different types of angles that you need to be familiar with. Here, you can see the 4 types of angles you need to be familiar with. So you would know what is a right angle. So a right angle is 90 degrees. So we will say this is a right angle. We call this an acute angle. Acute angle are angles which are less than 90 degrees. So I have written that in words. I've also written that in using mathematical notation. Angle A is less than 90 degrees. Next, you need to know what obtuse angle means. This is an example of an obtuse angle. Obtuse angles are angles between 90 degrees to 180 degrees. Next, you need to know what is a reflex angle. In this diagram, this angle here refers to the reflex angle. Reflex angles are between 180 to 360 degrees. Again, you may want to pause the video to ensure you have captured these 4 types of angles. Next, let us look at what is foot of the perpendicular. Now, a perpendicular means a line which is at an angle of 90 degrees to either another line or a plane. So in the example that I've drawn here, the line CD is perpendicular to the line AB. And we say that D is the foot of the perpendicular. It's basically where the perpendicular line meets the other line. So D is the foot of the perpendicular. Okay, next, let us look at some of the properties of angles that you would have learned in primary school. So when two angles add up to 90 degrees, we call these angles complementary angles. So in this diagram, if I tell you that this is 90 degrees, then it would mean that these two angles here will add up to 90 degrees. Therefore, we can say that the two angles are complementary angles. Next, two angles that add up to 180 degrees are called supplementary angles. Okay, so in this diagram, rather than using the diagram that's given here, I've drawn a different diagram which you may want to copy. So I have an angle here which is 140 degrees and an angle here that is 40 degrees. You can see that 140 and 40 will add up to 180 degrees. Therefore, we say that angle X and Y are supplementary angles. So as long as two angles add up to 180, we can call these two angles supplementary angles. Specifically, if the two angles that we are talking about lies on the same straight line, then these two angles would also add up to 180 degrees. But more specifically, here we say that this property is called adjacent angles on a straight line. So if the two angles are lying on a straight line, they add up to 180, we use this property. Of course, it may be more than two angles. It could be many angles lying on the straight line. We can still use this property. Next, angles at a point. So no matter how many angles there are, all the angles at the point will add up to 360 degrees. So we call this property angles at a point. Next, vertically opposite angles. Now, one of the key features for vertically opposite angles is that these two lines must be straight lines. So if they are straight, the two angles here would be considered vertically opposite angles and they will be equal. Similarly, the two angles on these two sides are also called vertically opposite angles and they will be equal. So this property is called vertically opposite angles. Now you will see that whatever reason we have written down in brackets are the reasons we will need to write down as part of our working when we are solving a question as well. So it's important that you identify the correct property, and this would be part of your working when you are doing questions on finding unknown angles. So let us look at how a question would look like. So let us turn to page 42 and look at example 1. So for example 1, the question wants us to find the value of B. You can see that angle B and the angle 122 lies on a straight line. So we know that these two angles would add up to 180 degrees. Therefore, we can use that property to find B. So this is what our working would look like. I can find angle B by taking 180 minus 122 and thereby getting 58 degrees. Now, other than writing down the working to get the answer, in the step that we wrote 180 minus 122, in brackets, we will need to state the reason or the property that we are using in this question. So this question, we are using the property adjacent angles on a straight line. Now you notice here I didn't write down supplementary angles because the reason why we know these are supplementary angles is because in this case the angles specifically lie on a straight line. So in such scenarios we can write down the specific property which is adjacent angles on a straight line. Similarly, for example 1b, there are three angles that lie on this line. So we know that the three angles would add up to 180 degrees. So how do we present our answer? In this question, do you see that there isn't a little letter written here? The previous question we had a letter B. So here there is no letter written. So the question uses angle COB notation. So we will use this to find angle COB. We take 180 minus the other two angles on the line. So this will give us the angle 19.9. Now at the same time, at the first line itself, when we take 180 minus the other two angles, the reason why we are doing this is because they are adjacent angles on a straight line. So do write down your reason at the step where you are using the property. Now let us look at question 2. Question 2, AOB is a straight line and we are asked to find the value of C. Now AOB is a straight line, so we know that this three angles would add up to 180 degrees. Now out of these three angles, two of it are unknown. The 2C is unknown, 3C is also unknown. However, because we know the three angles here would add up to 180 degrees, we are now able to form an equation. 2C plus 100 plus 3C must be equal to 180 degrees. Now we are able to form this equation because of the property adjacent angles on a straight line. So using this equation, we can then proceed to solve for C by balancing the equation. So after I've simplified the equation, I minus 100 on both sides and then I divide by 5 on both sides to find C. Now you can try question 2, example 2 on your own.